All right, so what I have here for you is a case where we have two students, Bolton and Leanne, trying to do the same problem. They're trying to find the LCD for this particular rational expression. Okay, can you tell me who is correct here? Is it Bolton or Leanne? Just look at it carefully. Just look at it. Give it about 5 seconds to think, and see if whether Bolton is doing this correctly or is it Leanne. Let me kind of zoom in a little bit here. So this is Bolton's side right there. You see how he did it? And over here, this is Leanne. Okay. Now, let's take a look at this whole thing. And anyone want to give me a feedback on this? Who? Yeah, go ahead. Isaiah.
I think Bolton did it.
You think Bolton did it correctly? Why?
Yeah.
You gotta have a good reason for it, right? Like, why do you think he did it correctly? See, I said to explain your reasoning. Okay, wait. Let me just go ahead and do a quick poll here. Who think Leanne did it correctly?
You just said it.
Okay. So, well, if you strongly think that Leanne did it correctly, just raise your hand and defend your answer. What about Bolton? Who think Bolton did it correctly? What about the rest of you? Undecided? Okay. Remember the technique to find the LCD. You gotta always ask yourself, did I actually have everything in its simplified form? So look at the original problem and ask yourself this. Is 2x plus 1 in its simplest form?
Yes.
Yes, then go ahead and put parentheses around it. Say, I'm done with that. What about x plus 1? Is that in its simplified form? Meaning there's nothing I can take out anymore. So if it is, put parentheses around it to say that, hey, this group is separate from the other. I'm done with that. What about x minus 1? Is it also simplified?
Yes.
It is. So if everything's already simplified and you're going to do a ladder on it, is there anything that you can actually take out that is uncommon? No. So what did you put outside then? If there's nothing to take out, a 1. So if this is your GCF, which is a 1, and this is your leftover, what is your LCD then? Yeah, that, which is on what on whose side? Bolton's side. Notice what Leanne did. Notice how I think about this. She was thinking, oh yeah, look at this. She said that x plus 1 here and x plus 1 looks the same, so she just wrote it one time. See how that worked? And I told you that as a group, you cannot compare it like that. You got to compare the entire thing as one whole group. Even though, yeah, you can try to defend it. Look, this looks so similar. You see the x plus 1, here's a 2x plus 1, very similar. But as a group, there's nothing in common about the 2x plus 1 and x plus 1. For you to have something in common, you better have the exact term inside. X plus 1, x plus 1. That's when you know they're in common. Okay, are we clear on that? And of course, in this case, Bolton is the correct, with the correct answers here. And I want you to use this technique to hopefully find the LCD, if need to. Okay? All right. Now let's take a look at our first problem here. And promise it looks a little bit intimidating at first, but if I have to give you a simple problem, it'll make more sense. Here's the problem. We call this complex fraction. Why? Because you notice that we have fractions within a fraction. Okay, but it's not complicated. Think about it this way. If I give you, okay, just put this problem aside for now. If I give you a problem like this, let's say 1 plus 9 divided by 2 plus 3, for example. What would you do for this problem?
Just add it.
Oh, just add what?
Both of them.
So at each level, right? Okay, fine. The top, 10, bottom, and that's a strategy. If you have mixed problems like this, you just have to separate the levels. Numerator, just take care of the numerator first. Take care of the denominators, and then we'll put the whole thing back together again. Okay? So if you look at this, yeah, exactly. If you think about this, isn't it like 2 problems in one?
Yes.
Here's a 1 problem right here. Here's another problem. And then actually 3 problems in one, because at the end you are dividing the whole thing.
Yes.
So what I would do, if I were you, is to organize this. I'll color code it for you. Look at this. Here's the top part, which is the green group. Here's the blue group at the bottom. So I'm going to go ahead and do the green first. Take a look at the green group. What can I do with those 2 fractions? Yes. A mixed number, by the way. Yes. No problem. Let's turn it into an improper. 3 1/2. How do you turn 3 1/2 into improper?
You multiply the denominator with the whole number
Okay.
and then add.
Which
the
becomes what?
7/2.
7 over 2. What about the 2 3/4?
And then
11/4.
Okay, that's easy enough. So that's the green group. Here's the blue. Watch this. I'm just going to go ahead and group them and color code them so you can see. Here's the blue. What do you have for the blue?
14 over 2.
14 over 3.
7/4.
7 over 4. And now, let's take care of the green. What is the LCD for 2 and 4? 4, right? So I have 4. And if I have a 4 here, what do I need to multiply the 2 by?
2.
2, which means 7 will also be,
14.
okay, good, multiply by the 2. Do I need to multiply anything to the 4?
No.
No, so fine. The top remains the same. I took care of my green. Let's take care of the blue.
Well,
What is the LCD for the blue?
12.
12. So here's the 12, here's the 12. And what do I need to multiply the 14 by?
Times 4.
Which is
56.
56. And the 7,
21.
21. Okay? Now, we just go ahead and group the green and group the blue. What is the green's going to become? What is it?
Oops, that's subtracted.
That's 3 over 4.
Okay, so this is going to become 3 over 4. And the blue,
87. No, 77.
77 over
12.
12. Is that easy enough so far? So now if you look at this thing as a whole thing, we have a fraction divided by a fraction. What is our strategy here when we take a fraction divided by a fraction?
you flip it and then multiply.
Flip which one?
The second one.
Which is the top and bottom. The bottom, okay? So we flip the second one, which is the bottom, and you end it with, here's the 3/4 times it, and we flip the bottom, which is 12 over 77, right? Okay. Now, at this stage, who would like to take 3 times 12 and then 4 times 77?
No.
No. What would you do?
Simplify. You can like.
And you're right. Here's a 12 and a 4. What can we do here?
4 divided by
Okay.
12.
If we divide each by 4, that means the top now becomes 3, and the bottom now becomes 1. So let's go ahead and erase that part. So the top now is just 9 over 77. And that's how we simplify the whole thing.
That's crazy.
Complex fraction for you. Is that good enough?
Yeah.
So we start with something very complex, but understand, hey, it's just like 2, 3 problems into one problem.
Is that
Separate them.
what we're doing?
Yeah, this is what we're going to be doing today. Okay?
That's an easier version.
But even with yes, go ahead, Mark. That's fine. Go ahead, Mark.
Could you keep that again?
What?
Which part? The whole thing?
The last purple.
Okay, the purple. Fine, fine. Mark, this is for you.
Yay. Come on.
No, that's fine. It's fine. Look. 3/4, right, Mark?
Yeah.
Divide, so I turn it into a multiplication problem, and it's 12 over 77, right? For you, instead of doing that, here, how about this? 3 times by 12. If you break down 12, what do you have? Here's another way to do it. 4 times 3, right? Watch. 3 times 4, right? The bottom, I already have the 4, so fine. Times 77. Look. Here's the 4, here's the 4. Cancel. How about that? They're all linked up on multiplications, right? Therefore, I can cancel the top and bottom. And you still end up with 9 over 77. Or just simplifying.
Oh,
Okay, there you go.
I didn't see what you did.
Huh?
I didn't see what you did before.
Okay. Alright. Cool. Alright.
Just a new one, so you can sort of write it like with the division sign. Like, so technically it's like a group and then like
Divided by. Yeah, so you can certainly read it horizontally too if you want. Alright.
Very good.
Okay.
Oh.
No. Don't panic yet. It's actually the same kind of problem.
Wait, I got you right here.
Okay.
Just put 2 over 1.
First of all, like always, because I want to show it clearly to you,
Wyatt,
I would put it into 2 separate groups. Here's the green, here's the pink group, okay? Take a look at the green. What is the LCD for the green?
6.
No, 6.
6. So I'm going to go ahead and write it out. Here's the 6, and here's the 6. What do I multiply the y by? 2. So it's going to be 2y, right? What about the 6? 1, so basically 5 remains the same. Take care of my green. Let's do the pink now.
put 2 over 1.
Good. Yeah, sure. There you go. And what's my LCD?
1, 1.
Okay, so basically just y, right?
So it's
Okay.
2y,
What do I multiply the 2 by?
2y.
2y. Okay. My y. Okay. What about the 5?
Leave it.
Leave it because you already have the y.
Yeah.
Right. Okay. Let's combine. What's the top the green is gonna become?
It's
2y plus
3.
2y plus 5. Yeah.
2y plus 5. Watch what happened.
Oh,
It is simplified, right?
yes.
And it is now as a group, so I put them together as a group. I put an extra parenthesis just to remind you about it. Over 6. Look at the pink now. If you put it together, what do you have?
2y plus 5.
2y plus 5. So 2y plus 5 once again, I group them together over
Oh, wow.
y. So when you divide fractions, yes,
Can we cancel off the 2y and the plus 5?
not yet, not till we, not this way yet, not till we put it back into the multiplication format. Remember?
Okay.
Remember I told you that it has to be all linked up by multiplication before you can certainly cancel stuff out. So
Okay.
if you're gonna put this together as a multiplication problem, what do you have?
You have 2y plus 5.
Okay.
C over 6.
Okay,
And then y
times something.
times y over
Y.
2y plus 5.
See now you can say, look, can we now cancel out the 2y plus 5 because look, is this linked up by multiplications?
Yes, it is.
And because I have the top and bottom look exactly the same as a group, I can cancel it out. And so my final answer,
Y over 6.
and that's it.
We win.
Let's cut it.
Okay, so it looks complicated at first, but you got to realize that this is what we're doing. Here's the strategy: take care of the top, take care of the bottom, and then we'll divide by switching it to reciprocal. Turn times it by reciprocal, right? Question on this problem.
No.
Easy enough.
Yep.
Okay.
Where's the quiz?
Not yet. Not yet. Too early for one. But
He's going up and up and up. See? Look at it. That's.
it's a great build up, right? In a sense. Look at this. Can anyone tell me how many groups do we have here?
2.
2. So once again, here's the green, and here is the whatever. Okay. All right, look at the green. What is the? Actually, go ahead. What is the LCD?
XY.
That's why.
Okay, and the bottom.
YX.
Does it matter if it's X, Y, or YX?
Yes.
No.
Think. Okay, good. Good that you're kidding. Okay, here's the XY. Here's the XY. That's the top, and the bottom, as you can see, is also XY, right?
Yeah.
But this time it's minus. Okay. Now, the top. What do you multiply the 1 by on the left?
Y.
Y.
Okay,
Y.
good.
Y1,
And over here?
1y, whatever.
Okay. What about the pink?
X.
X. And here?
Y.
Y. Let's put them all together.
Yeah. Yeah.
What do you have for the green?
Y plus X over X.
Okay, notice you said X plus Y. Is it okay if we say Y plus X?
Yes.
Okay, so why is it? Why is it that we say X?
Because we're still combining it. Don't matter.
Why is it the commutative property? X plus Y, Y plus X?
That's what I
2
said.
plus 3, 3 plus 5, 2, the same thing, right? So for the green, don't you just simply have X plus Y as a group over XY? What about the pink?
You put
X minus Y?
Okay, now is it okay for us to say Y minus X?
no,
Why?
Because
Because you can't flip it, otherwise it's gonna be a different value.
it's like no.
And what she said too, that there's no commutative property for subtraction simply because of this. You can take 10 minus 5, but not 5 minus 10. It's not the same. They're not the same. Okay, so be careful with that. And notice how we are multiplying this time, right?
Yes, sir.
And the pink now will take the reciprocal, which becomes the following. Do we see anything that we can cancel out?
It's both of them.
Which one?
No.
Oh wait, no, that one. X and Y.
X, Y.
Anything else?
No.
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 Anything else?
No.
Can we cancel X plus Y and X minus Y?
No.
Are they the same? They're not, right? Don't. Yeah, which a lot of you will probably do something like this too. Like, they look almost the same except for the sign. And I told you as a group they must look exactly the same, down to the sign as well. So because of that, we only have X plus Y over X minus Y. And that will be our simplified answer. Okay? Alright.
Yeah.
Not yet. This one right here though, I want you to go ahead, listen. I want you to go ahead and try this problem out by yourself. So I'm going to go and give you a couple of minutes here to work this through. Go ahead, work your magic.
Hey, come on.
Hey.
Is that one?
T minus. What?
Is that one?
I want to 3, I give up.
Okay.
Is it two separate?
Hey, it looks very familiar if you look at it carefully. All right, now look at this carefully, okay? When you look at a problem, observe it and see if you can actually recognize any pattern. For example, look at the t squared minus 4. What does that remind you of?
Stop.
Dots, right? And what about the t squared plus 5t plus 6? What do you do with that? Try
I
now.
Xboxed it.
Xbox
And I
it.
did it, and I don't know if I got it right.
Okay, let's check. Here's the top, and here's the bottom group, okay? Look at the top group right here, which is in purple. Let's take a look at it again. If you break down the dots, notice I put in extra parentheses on the top because, I'm done with that. What about t squared minus 4? What can that be broken down to?
T minus
T minus
T
2, T plus 2.
Okay, you know they're always opposite sign because that's what's special about dots. Okay, now look at the bottom. 1 over, look at the t squared plus 5t plus 6. You said that we can certainly perform what on? Xbox it, okay. Or, okay, here's a 6, here's a 5.
2, 3.
2 and 3. Some student thought that it's like this.
I told you, didn't I tell you? I did not
Think about it. Yeah, fine. 6 plus -1 is 5, but what about 6 times -1? It won't give you positive 6, so it won't work. You know that you have to give me the combination that has to satisfy both, the product and the sum.
Wait, it's 2.
Okay. 2 times 3 is 6, 2 plus 3 is 5. Do we need a box on this?
No.
No, we don't, right? But you can certainly just write it out. Here's the t plus 2, t plus 3. But for our students' sake, look, even if you want to go through with the box, I want to take this time to review with you too. With the box, what do we have to write this into?
T squared
4 times the t squared.
plus 2t plus 3t plus 6.
And if you know this already, you don't have to write it, right? You just have to fill in the box. And here's the box. I got t squared, 2t, 3t, 6. What can I take out here?
T.
T, and here?
3.
3. So we pair it up,
2.
and 2, right? Check. And that's how we got 2 plus t plus 2, t plus 3, right there. So box or not, in this case, we can get the same exact answer because the first term right here has a coefficient that starts with a positive 1. It has to be a positive 1 for you to bypass the box. If it's any other number, that you have to go through the box. Okay? Alright, so there it is. Now that we have this, what do we do? Okay, reciprocal. Very good. So let's take a look at it. I have t minus 2. I have t. Oh, wait. Can we cancel this out?
Yeah.
Yes, we can. There it is.
Oh, man.
That will simplify it even more. That means we only have 1 t plus 2. And over here, times it by t plus 2, t plus 3, over 1. Oh, look at this.
Oh,
Oh, so the answer is
I got it.
just t plus 3.
everybody Nico got it, okay?
Yeah.
You see how easy this is?
Yeah.
Okay. Well, not all that work. If you think about it, it's not much. Okay? Because it's all about, do you know the factor? If you know, you can cancel a lot of those terms out. But there it is. We have ourselves, this is called complex rational expressions, right? And what's involved is basically fractional problems, divisions. That's it. Okay. Are there any questions right here?
No.
Alright, like to stop right here then?